Okay, today we are going to do our first AP review topic, that being area and volume. The problems that we are going to be working are AP free response questions. For each problem, it's going to tell you which question you are looking at. For example, this first one is 2004. Version B. Every year there's two versions, an A version and a B version. Problem number 1, and it tells you it was done with a calculator. So the way these packets are going to be set up is you're going to have two problems that we're going to do together as a class for notes, followed by two problems that you will do in class with your groups, and then the last two problems you're to do on your own for homework. Now, if you don't finish the group work in class, you still have to finish the group work independently as homework. Every one of these packets will get 2 grades. A completion grade, where every part is weighted equally, and an accuracy grade, which we will score using the AP scoring rubric. Every AP free response problem will earn a total of maximum 9 points. Generally speaking, if you get 6 out of the 9, you're shooting for a 5 on the AP exam. If you get somewhere between 4 and 5 points per free response question, you're looking at getting a 4 on the AP exam. If you get 3 points out of the 9, so just a third, then you're looking at getting a passing score, a 3 on the AP exam. And so when I do your accuracy grade, we're going to look at the scoring rubrics for these problems and grade them together. And we will adjust the scores according to the way the AP test would score. So you don't have to get 100 to get 100. It'll be scaled up. And we'll go over that in a little bit greater detail when we start grading these together. I do want you to have the experience of grading your own work. So if you're not here when we grade it in class, I'm going to ask that you come in before school, after school, at some point other than class, to go ahead and sit down with the rubric and grade it yourself, because one of the valuable aspects of doing the AP review is looking at the rubrics and seeing how your points would be distributed. You learn almost as much from that as you do from actually solving the problems. So you'll get the most points on the AP exam. All right, I think that's about all the beginning information I wanted to talk to you about. So let's get started on working some problems. This first one says, let region R be the region enclosed by the graph of y equals the square root of x minus 1, the vertical line x equals 10, and the x-axis. So you might want to sketch a little graph of this region. This is with a calculator, but you probably don't need a calculator to do this. Y equals the square root of x minus 1 is the parent function. The square root parent function shifted 1 unit to the right. So instead of beginning at the origin, it's going to begin 1 unit over to the right on the x-axis. And then it has your general square root shape. The vertical line x equals 10 will be plotted somewhere around like this. And let's see, where will those intersect? If I were to plug 10 in for x in my y equals equation, it'd be the square root of 10 minus 1. So the square root of 9 would be 3. So this is the coordinate pair 10, 3, where the two this is not a function. This is definitely not going to pass a vertical line test. X equals 10, where the two equations meet. And then we've got the x-axis as the other border. So the region that we're talking about here is this region shown. So we are to find the area of that for part A. So you'll remember the area between two curves would be the integral from the leftmost x, which would be 1 here, to the rightmost x, which would be 10, of the upper function minus the lower function, but the lower function, it just has an equation of y equals 0. So really we just need square root of x minus 1, and then dx. Now, this is a calculator problem. You are supposed to be doing definite integrals in the calculator on the calculator problems. So show your integral setup, then plug it into your calculator. Make sure that you're doing this and practicing getting the answers so that you can make sure that you are entering these all correctly. So you can pause the video if you need to. Then the answer to this will be 18. So make sure that you got that correct. Check with a friend if you did not. Okay, part B says, find the volume of the solid generated when R is revolved about the horizontal line y equals 3. So y equals 3 is a horizontal line that's going to go right through that tip-top point of our region R. So we're going to revolve it around that. So when we find the volume of a solid of revolution, first we want to say, is our independent variable supposed to be x or y? Well, if I'm rotating around a horizontal line, like the x-axis is a horizontal line, then I'm dealing with x as my independent variable. So our integral is going to be from leftmost x to rightmost x, 1 to 10. Then we've got to figure out, is the shape of our cross-section going to be a circle or a washer? It's always measured perpendicular to the axis of revolution. So in this case, this little region would kind of flip up across it, and you're kind of forming a solid like this. So there is a gap between the region and the axis of revolution, which forms a washer for the cross section. So we are going to integrate pi big radius squared minus pi little radius squared dx. So now we just need to figure out what these radii are. So the outer radius remains constant throughout this entire process from the line y equals 3 to the x-axis. That's a distance of 3. So you're going to have the integral from 1 to 10 of pi times 3 squared, or you could just say 9, minus pi times the little radius is the vertical distance from the curve up to the line y equals 3. So it's basically 3 minus the y value of our function. Since y is equal to the square root of x minus 1, we can just say 3 minus the square root of x minus 1 is our radius. Square that, dx. Now, I wouldn't recommend simplifying this at all. I'd just put it in the calculator. This is the calculator portion of the test, and get your answer. You're welcome to pause the video while you type that in and then see if you get it right. The answer for this one is 212.058. That's what you're looking to see that you can get. All right, the last part of this problem, part C, says find the volume of the solid generated when the region R is revolved about the vertical line x equals 10. I wonder if there's a way for me to clear this text. Well, I can erase it. All right, so I'm going to take this region R and revolve it around the vertical line x equals 10. So x equals 10 was right here. So we're revolving this way. So it's going to come back down on the opposite side, sort of like this. It's going to look kind of like an anthill. So this time, my axis of revolution is vertical, like the y-axis. So I'm now going to be integrating from lowest y to highest y. So the lowest y is 0, the highest is going to be this uppermost point, which we determined the coordinates were 10, 3. So it's 0 to 3. Now, since our axis of revolution has the region pressed right up against it with no gap in between, the radius touches this axis and we don't have a gap. So we're going to just have pi r squared dy. Again, integrating with respect to y because we have a vertical axis of revolution. So now we just need to figure out what r is. Well, we know the distance from the y-axis over to the line x equals 10 is 10 units wide. The radius, r, is smaller than that. It's 10 take away whatever the x coordinate is at any given point. So the radius is equal to 10 minus x. But here we're dealing with y as the independent variable. So I want to do a substitution in my function. Up here I have y equals the square root of x minus 1. So I want to get x by itself in terms of y. So if I square both sides, y squared equals x minus 1. And if I add 1 to both sides, y squared plus 1 equals x. So the radius is equal to 10 minus the quantity y squared plus 1. You can distribute the negative if you want and then combine like terms. It's not necessary. This is a calculator portion. Probably the less manipulation that you do before you put it in your calculator, the better. Less likely that you'll make a mistake. So the volume is equal to the integral from 0 to 3 of pi times our radius, 10 minus the quantity y squared plus 1. All of that radius squared. Watch your parentheses when you put this in the calculator because you need to make sure that you are squaring this entire radius. Also, your calculator cannot enter in y as the independent variable, so you're just going to pretend like the y's or x's when you put it in the calculator. You don't want to write it that way though, because in your work you need to show that you know what the independent variable for this given situation should be. Alright, so if you type that in your calculator, and you're welcome to pause the video and make sure you can get this correctly, your answer should be 407.150. This 0 cannot be left off because the decimal continues beyond that, and even if the last digit is a 0, it has to be included when you're rounding to 3 decimal places. So I wanted to make special mention of that. Alright, let's talk about how this problem is scored on the AP Calculus exam. Okay, so the scoring for our first example that we just did, 2004B, problem number 1. For part A, it's worth a total of 3 points. And the way they give you those 3 points are 1 point for the limits of integration. So having the 1 to 10 on your integral. 1 point for the integrand, so integrating square root of x minus 1. And then 1 point for your answer, which was 18. So, if you got the answer wrong, because you entered it in the calculator wrong, it's possible you could still get 2 out of the 3 points. If you didn't know how to set up the integral, it's possible you could get 1 out of the 3 points if you could just at least figure out what the limits should be on your integral. So, lots of opportunity for some partial credit. On part B, it's also worth 3 points. You get 1 point for having the limits and for having, they call it the constant, but the constant we're talking about is pi. A lot of the time on the scoring guidelines, they pull the pi out in front of the integral symbol. Some textbooks teach the formula that way, but anything algebraically equivalent is fine. So the pi can be in front of the integral symbol, or it can be in front of each of the radius squared parts of the integrand. Either place, but having the limits and pi both correct give you 1 point for this problem. The second point is for the integrand, which would be pi big R squared minus pi little r squared with the correct radii in each. And technically speaking, the pi would not have to be there, because if you have a problem with the pi, that would come off of that first point. So it's more the big R squared minus the little r squared that they're grading on your integrand. Then your last point is for your answer. And for your answer, they will accept 212.057 or 212.058. So that last digit can be rounded, or you can truncate, which means just cut off the 4th decimal place and beyond. They'll take either one of those two answers. All right, part C is also worth 3 points. So the total is 9, and the total is always going to be 9. You get 1 point for your limits of integration and the constant, which is pi. 1 point for the integrand, and then 1 point for your answer. And again, that has to be rounded to 3 decimal places, so the 0 has to be there. All right, we've got another problem to do. This one comes from the 2004 test A version, problem number 2, and it's with the calculator again. So it says, let f and g be the functions given by f of x equals 2x times the quantity 1 minus x. You can see that graph graphed as the upper one up here. Notice if you were to distribute that 2x into the parentheses, you would have a quadratic equation with a negative a value, so the coefficient of x squared would be a negative, so that gives you the downward opening parabola. We also have g of x, which is equal to 3 times the quantity x minus 1 times the square root of x. So that's not just a simple parent function kind of a deal. That's kind of a strange function we're working with. They have this one graphed down below. And it says for x values from 0 to 1. So this is a calculator problem. If you were going to put these in your calculator, you definitely want to change your window so that you're not going all the way out to 10, because that part does not matter. We're only looking from 0 to 1 on this. So the graphs of f and g are shown in the figure above. Part A, find the area of the shaded region enclosed by the graphs of f and g. So for A, we're going to find the area, which is equal to the integral from leftmost x to rightmost x, so that's 0 to 1, of upper function minus lower function, so that's f of x minus g of x dx. Now, you can write it out with the functions' names or with the actual functions. You're going to have to type it in your calculator. So I would recommend just using the functions' names when you're showing the work on your paper because it's less writing and less time. This is a time test. You want to be careful about your time. Okay, so when you type that in your calculator, which you can pause the video and take a moment to do that, then check your answer. Your answer should be 1.133. Please do be checking to make sure that you can enter these correctly into your calculator. Every year we have multiple students realizing that they are doing something incorrect in the calculator. It's so much better to realize that now when we're in the practice and review phase for the AP exam than not discover it till you're taking the test and you end up making a poor score. Okay, part B. Find the volume of the solid generated when the shaded region enclosed by the graphs of f and g is revolved about the horizontal line y equals 2. Notice on the y-axis they've only graphed up to y equals 1. So y equals 2 is going to be way up above. So it's going to rotate around this line. There's definitely a large gap between the axis of revolution and the region that we are rotating. So we are going to have a washer for our cross section. So when we work our volume formula, the volume is going to be equal to the integral from, this is a horizontal axis of revolution, just like the x-axis is horizontal. So it's leftmost x to rightmost x. So that's going to be from 0 to 1. And since our cross section is a washer with the big gap between the region and the axis of revolution, we're going to be integrating pi big R squared minus pi little r squared. And it is dx because we have the horizontal axis of revolution. X is our independent variable. So now we are going to have to figure out what the radii are, big radius and little radius, for this problem. So the big radius is the distance from the axis of revolution all the way down to this lower curve. That's big R. Little r is from the axis of revolution to this upper curve. Okay. When you're trying to find a vertical distance on the coordinate plane, you can take the upper y value and subtract the lower y value from it. So our big radius is going to be 2 minus g of x. Oops, I'm using the wrong color. Whoa, I hit the wrong thing. I got this giant arrow. I don't have anything to point it at. Okay, where is the eraser? No. Okay, well, I'll just write over this one. Big radius equals 2 minus g of x. Notice that the g of x values, y values, will be negative because this entire g of x function for this portion graphed is in the fourth quadrant. The y values are negative. So when I subtract a negative value, it's actually going to add that on there to the number 2. So we've got 2 as the distance from the x-axis up to the axis of revolution. And then we've got the positive y value because we're subtracting the negative y value added to it. Now the little radius is going to be 2 minus f of x's y value. So little r equals 2 minus f of x. And we can just plug those values in to our formula. Volume equals the integral from 0 to 1 of pi times the quantity 2 minus g of x squared minus pi times the quantity 2 minus f of x squared dx. So then you're going to type that in your calculator. Feel free to pause the video and give yourself as much time as you need to do that. When you do, you can check your answer, which should come out to 16.179. Okay, we've got one last part to do together as notes. That is part C. And part C says, let h be the function given by h of x equals kx times 1 minus x. So we've introduced another variable in this problem, k, but k is a constant. Notice, please notice the similarity between the h of x equation and the f of x equation that they gave us to use previously. They are the exact same thing, except for they've taken out the 2 and replaced it with k, so that could be any variable, any constant, sorry. So it's still going to open, well, let's read on. For x values from 0 to 1, so the same as we had before. For each k greater than 0, so we're only looking at positive values of k, that's important. The region, which is not shown because I didn't graph this h function, enclosed by the graphs of h and g, is the base of a solid with square cross-sections. Square cross-sections perpendicular to the x-axis. There is a value of k for which the volume of this solid is equal to 15. Write, but do not solve an equation involving an integral expression that could be used to find the value of k. All right. So basically, we're going to need to set up an equation to find the volume. This is a solid of known cross-section. And that was our first day of volume that we learned about. We're going to write the equation and not solve it for k, but it needs to be solvable for k. So, how's that going to work? Well, if it's a volume, it's an integral. And the cross-sections are perpendicular to the x-axis, so x is our independent variable. Lowest x is 0, highest x is 1. Now, if you'll remember, when we're doing solids of known cross-section, we integrate the area of the cross-section, which is really what we do on solids of revolution too, because the cross-section is a circle or a washer. But for this one, it's a square. So all we need to know is what is the base of our square, and then multiply by itself, or square it, for the area. So I need to know, okay, if my base of my square is perpendicular to the x-axis, then it starts somewhere up here and goes to down here. How do I find that distance between the upper function and the lower function? Now I'm using f of x as a model for h of x, but they're not the same. They could be if k was 2, and 2 does fall in the greater than 0 category, but k could be any positive number. So we might have a parabola that's steeper or flatter than the one shown, but basically the f of x function is a good model for the h of x function. It is one special case of it. So if I want to find the distance from my h of x function to my g of x function, I just take upper function minus lower function. So I am going to have h of x, which is the one on top, and I know that because k has to be positive, so it can't be reflected. H of x minus g of x. Take that quantity and square it, dx. This has to equal 15. Oh, I figured out how to erase. Okay, it has to equal 15. So when you say write an equation must have an equals in it, and it has to equal whatever they tell you, 15 for this problem. Now, this is great. I've got a volume equation equal to 15. Is it possible to solve it to find K? No. Why not? Because I don't have a K in it. All right, well, we can't just use function names then. That's not going to work. We can't solve it like that. So if it could be used to find the value of K, we need to just use the actual functions themselves. So it's going to be the integral from 0 to 1 of h of x, which is kx times 1 minus x, the quantity 1 minus x. That function minus g of x, which is 3 times the quantity x minus 1 times the square root of x. All of that squared with a dx. So that is the integral, and that should be set equal to 15. I did not leave enough room there to make that look nice. This will not happen to you on the AP exam because for every single part, they give you either a half a page or a whole page worth of space. Like one single free response question, like this 3-part question, will be the 2 open faces of a page when you open it up facing you in your test booklet to write on. So there's lots of room. And I'm sorry that I didn't replicate that, but I didn't want to waste that much paper. Test booklets use a lot of paper. Okay, so that's the equation. Let's talk about how this problem would be scored. So, on part A, it's going to be worth 2 points. 1 point for the integral, and then 1 point for the answer. When it says integral, that would include the limits, so it's the integrand and the limits. Notice this is not the same way that they graded the area problem on the last one. This is why I want you working lots of AP problems and looking at the scoring rubrics for lots of AP problems. There are definitely patterns and trends in how they score the problems, but they are not consistent. And so it's important to look at the different things they might do to make sure you've got all your bases covered when you're trying to get partial credit for your work, as many points as possible. So part B is actually worth 4 points on this problem. And the way they allot the points is like this. You get 1 point for your limits and for the constant pi. You get 2 points for your integrand, and the way they handle this is minus 1 point for each error that they find, but they will not give you any points if you don't have it as pi big R squared minus pi little r squared. So say you just thought it was a circle cross section instead of a washer, and you only had pi and then one of the radii squared. They would not say, oh, that's just minus 1. You'd get no points for that. The kinds of things they would take a point off for is more like if you had one of the 2 radii incorrect, or if you left a square off or something like that. But once you've lost your 2 points, they're gone. Then 1 point is for the correct answer, rounded correctly. Part C is worth 3 points, and they do that with 2 points for the integrand, and then 1 point for what they call the answer. And when they say the answer, like you didn't actually calculate a value on this one, they mean like your equation set equal to 15. That's what they're really looking for there. So the integrand is 2 points. And again, they usually say minus 1 for each little error that they find until your 2 points are gone. All right, I hope that you gained some insight about how the AP free response questions look and how they're scored. This particular topic of area and volume is very frequently tested. Often there's a common problem on the A, B, and BC problem that you see on both tests, and it usually is of this variety. So they do a lot of these. So practice in your groups with the next two problems, then the remaining will be for homework, and we will be grading these together in class at a later time. You might want to start bringing, or some of you have already been bringing a colored pen to class for grading purposes, but I would especially like you to start doing that again if you got out of the habit. And trying to think if there was anything else I needed to tell you about this. I don't think so. So good luck, have fun, happy calculus. Bye.